Hello, this is Mr. Olmec, and we're going to start talking about section 5.2, which is the rational expression section. All right, we'll start with just like the definition of what a rational expression is. A rational expression is written as a fraction of polynomials. So if you have a fraction p of x divided by a fraction q of x, and p and q are both polynomials, then that is a rational expression. As before, anytime we have a fraction, the domain is found by setting the denominator not equal to 0. And so since in this case we have q in the denominator, wherever q of x is equal to 0, that is what the domain is not allowed to equal. And so it has how we write it out here in our set notation. Alright, so what we're going to do is we're going to do a couple of examples where we're just finding the domain. So this should be something that's familiar to everybody. So if I want to find the domain of the following problem, we'll write it out and we'll go through it. And so let's say our problem is r of x equals x minus 6 over x plus 2. So in this case, if I want to find the domain, all I do is I take the denominator. So we take our denominator, which is x plus 2, and we need to set it not equal to 0 and solve. So to solve this, subtract 2 from both sides. So x cannot be negative 2. And so our domain, the way we write it, is it's the set of all x such that x cannot be negative 2. And that is how we would find our domain. Alright, not every problem is going to be that easy though. Some of them might be a little bit more difficult. And so whenever we're looking at a little bit more involved problems, we might have to do a little bit more, but probably not a whole lot more. And so let's see if I have r of x equals 2x minus 9 divided by x squared plus 5x minus 6. If I have this rational expression and I want to find the domain, I would take our denominator, x squared plus 5x minus 6, and set it not equal to 0 and solve. So since this is a quadratic equation, we would solve this by one of our three methods. In this case, this is factorable, so we're going to factor. And then once we factor, we'll set each of those not equal to 0 and solve. So there will be two values that are going to be excluded for this problem. And so if I'm looking for two numbers that multiply to negative 6 and add to positive 5, that's going to be a positive 6 and a negative 1. And so when we're solving, that means x plus 6 is not allowed to be 0, and x minus 1 is also not allowed to be 0. So through solving, we're going to get two solutions. X can't be negative 6, and x can't be 1. And so writing this out in set notation, we'd have the set of all x such that x cannot equal negative 6 or 1. So we just separate them with a comma and close our brace. Okay, and for our next example, we're still doing the same thing. In this case, our denominator is x squared plus 3. And so we will take x squared plus 3, and this is not allowed to equal 0. And so solving this problem, in this case, we will notice that it is quadratic, but there is no middle term. So we're going to solve this one directly by moving the 3 over and taking the square root. So we'll first subtract 3 get x squared is not equal to negative 3. Then to cancel out the squared, we'll take the square root of both sides. Remember, whenever you take the square root, we get our plus or minus sign. The square root of negative 3 is I root 3, since a negative is an imaginary number. And so our domain is x is not allowed to be the positive I root 3 or negative I root 3. And since these are both imaginary solutions, that means we're getting rid of imaginary answers. So therefore, when we talk about the domain, there are no real values being excluded. So our domain is all real numbers. Alright, and so for this fourth example, one thing we'd notice whenever we look at this rational equation is that we have a factor of x plus 6 in the numerator and in the denominator. So if we were simplifying this and graphing, we would go ahead and cross these out. We would just go cross this out and then cross one of the x plus 6 out. So it would take one away, there'd be one left. But since we aren't doing that just yet, we're just finding the domain. It's really not necessary to do that. We usually find the domain before we cross anything out. And so even though this is going to eventually cross out with the factor in the numerator, it doesn't matter. The way we find the domain is always going to be the same. You take your denominator, whatever your denominator originally is, and that is not allowed to be 0. Alright, and so we'll just solve from here. So in this case, it will be pretty quick, and we'll have the domain is the set of all x such that x is not equal to negative 6.